July 18th, 2024. Deep inside Mission Control at NASA's Jet Propulsion Laboratory in Pasadena, California, a room full of scientists leaned closer to their screens. The Perseverance rover, crawling across the rust-colored surface of Mars 140 million miles away, had just transmitted an image that would change everything. A rock, reddish-brown, shaped like an arrowhead, sitting in an ancient dried riverbed that hadn't seen water in over 3 billion years. But this wasn't just any rock. As the high-resolution images flooded in, one scientist broke the silence. "My God, look at those spots!" The rock was covered in markings that looked disturbingly familiar. Dozens of pale splotches, each one ringed with a dark halo, like the spots on a leopard's coat. On Earth, patterns exactly like these are left behind by only one thing: life. Microbial life, feeding, breathing, consuming organic matter, and leaving behind mineral fingerprints that last for billions of years. The mission scientist stared at his screen, his hands trembling slightly. "This is it," he whispered. "This might actually be it." They named the rock Cheyava Falls, after the tallest waterfall in the Grand Canyon, and for over a year it has haunted the dreams of every astrobiologist on Earth. Because if those leopard spots mean what they appear to mean, then humanity is no longer alone in the universe. We never were. Life existed on Mars. It thrived in its ancient rivers. It left proof behind, and we just found it. But here's where the story gets complicated. Here's where NASA's most brilliant minds find themselves trapped in a maze of contradictions, unable to give the world the answer it desperately wants. Because the evidence is extraordinary, and as Carl Sagan once said, extraordinary claims require extraordinary evidence. And right now, even NASA doesn't know if they have enough. This is the story of the most important rock ever discovered, a story of dead rivers and ancient organisms, a story of leopard spots and ghost minerals, a story that could rewrite everything we thought we knew about life in the cosmos, and a story that might remain forever trapped on Mars, unable to reach Earth because of money, politics, and the cruel mathematics of space exploration. The clock is ticking. The truth is sitting in a titanium tube on a dead world, and NASA is running out of time. To understand why Cheyava Falls matters, you need to understand where it was found. Jezero Crater on the northern hemisphere of Mars, a massive impact basin 28 miles wide, carved into the Martian surface by a meteor impact billions of years ago. But Jezero isn't important because of the impact. It's important because of what came after. 3.5 billion years ago, when Mars still had a thick atmosphere and liquid water covered parts of its surface, a river carved its way into Jezero, rushing downhill from the highlands, carrying sediment and minerals in a torrent that would have dwarfed the Amazon. The river dumped into Jezero Crater, creating a deep lake that existed for millions of years, a lake where clay settled on the bottom, where organic molecules accumulated, where, if life ever existed on Mars, it would have had everything it needed to survive. NASA knew all of this before they sent Perseverance. That's why they chose Jezero. If you want to find life on another planet, you don't search randomly. You go where the water used to be, where the chemistry was right, where conditions existed that could have supported the same kind of microbial organisms that dominated Earth billions of years ago. Perseverance landed in Jezero Crater on February 18, 2021. A perfect landing, using NASA's famous sky crane system, where rocket thrusters lowered the rover gently onto the Martian surface using cables. The mission was clear from day one. Drive through the ancient lake bed, study the rocks, drill core samples, store them in titanium tubes, and wait for a future mission to bring those samples back to Earth for analysis. For 3 years, Perseverance crawled across Jezero, drilling into rocks, analyzing minerals, taking photographs that revealed layer after layer of sedimentary rock, the kind formed by water depositing material over long periods of time. And yes, they found organic molecules, carbon-based compounds, the building blocks of life. But organic molecules aren't life. They form naturally through chemistry. You need more. You need evidence of metabolism. Evidence that something was consuming those organic molecules and using them for energy. Evidence that something was alive. And then, in July 2024, Perseverance drove into Cheyava Falls, an ancient river channel a quarter-mile wide that once fed water into Jezero Crater with tremendous force. The rover was exploring a formation called Bright Angel, rocky outcrops along the edges of the dry riverbed, and that's when it found Cheyava Falls. The first thing the science team noticed was the veins, thick white lines of calcium sulfate running through the rock like cracks in glass. Calcium sulfate is gypsum, the same mineral found in desert roses on Earth, and it only forms one way: water. Liquid water flowing through cracks in the rock, depositing minerals as it evaporates. This rock had been soaked in water for extended periods. That was the first clue. But then the rover's instruments got a closer look, and that's when they saw the spots. Dozens of them, irregularly shaped, a millimeter or two across, pale off-white centers surrounded by dark black rings. The science team called them leopard spots, but they also used another term: poppy seeds. Tiny mineral accumulations scattered across the rock's surface like seeds sprinkled on bread. And when Perseverance's instruments analyzed the chemical composition of those spots, they found something that made everyone's heart race. Iron phosphate in the pale centers, iron sulfite in the dark rings. On Earth, this exact combination of minerals forms almost exclusively through one process: microbes. Dr. Joel Hurwitz, the lead scientist from Stony Brook University, explains it like this. When bacteria or other microorganisms consume organic matter, they use chemical reactions to extract energy. These reactions involve moving electrons between molecules, shuffling iron between different oxidation states. Iron gets reduced, iron gets oxidized, and as byproducts of these reactions, specific minerals crystallize out. Vivianite, a hydrated iron phosphate that forms near decaying organic matter. Greigite, an iron sulfide that certain microbes produce as part of their metabolism. And when these minerals form together in sediment, they create distinctive patterns. Pale cores where iron was stripped away, dark halos where iron accumulated, leopard spots. The science team ran every test they could with the rover's instruments. The rock showed organic carbon, sulfur, phosphorus, oxidized iron, all the ingredients life needs. The temperature history suggested the rock had never been heated to scorching temperatures that would have destroyed delicate biological signatures. And the age of the rock, estimated at around 3 billion years old, placed it in the window when Mars still had surface water, when the planet was still potentially habitable, when life, if it ever existed, would have been at its peak. Dr. Nikki Fox, NASA's Associate Administrator for the Science Mission Directorate, stood before the cameras in September 2025 and said the words that made headlines around the world. This is the closest we've actually come to discovering ancient life on Mars. She paused, choosing her words carefully. The identification of a potential biosignature on the red planet is a groundbreaking discovery. Potential biosignature. Not life, not proof, potential. That one word carries the weight of scientific caution, because as compelling as Cheyava Falls appears, there's a problem. Actually, several problems. Problem number 1, olivine. When Perseverance examined the white veins running through Cheyava Falls, it found something unexpected. Tiny green crystals of olivine embedded in the calcium sulfate. Olivine is a mineral that forms from magma, from molten rock cooling at high temperatures. It doesn't belong in a sedimentary rock formed in a cool river environment. So how did it get there? One possibility is that volcanic activity occurred nearby and hot fluids carrying olivine infiltrated the rock later, depositing the crystals. That's fine. That doesn't invalidate the leopard spots. But there's another possibility. What if the olivine and the spots formed at the same time? What if hot magmatic fluids carrying dissolved minerals at uninhabitably high temperatures flowed through the rock and created a chemical reaction that mimicked the patterns of biological activity? What if the leopard spots have nothing to do with life at all? This is the nightmare scenario that keeps NASA scientists awake at night. Because on Earth, when we see vivianite and greigite together, we can dig deeper. We can slice the rock into microscopic sections. We can use electron microscopes to look for fossilized cells. We can analyze isotope ratios that reveal whether the carbon came from living organisms or from abiotic chemistry. We can run dozens of tests that would settle the question definitively. But Cheyava Falls is on Mars, and Perseverance's instruments, as advanced as they are, have limits. The rover can measure chemistry, it can identify minerals, but it can't see cells. It can't detect the subtle isotopic signatures that separate biology from geology. It can only say, "This looks interesting, this needs further study." Dr. Kenneth Farley, the Perseverance project scientist, was blunt in his assessment. To fully understand what really happened in this rock, we need to bring the sample back to Earth. And there's the problem. Bringing samples back from Mars is one of the hardest things humanity has ever attempted. And right now, that mission is in serious trouble. The Mars Sample Return Mission was supposed to be NASA's triumph. A multi-billion-dollar collaboration with the European Space Agency involving not one, not two, but 5 separate spacecraft working in coordination to retrieve the samples that Perseverance has been collecting. The plan was audacious. Send a lander to Mars equipped with a small rocket. Send 2 helicopters to retrieve the sample tubes from Perseverance or from the backup depot the rover created on the Martian surface. Load the samples into the rocket. Launch the rocket into Mars orbit, the first rocket launch from another planet in human history. Rendezvous with an orbiter provided by Europe. Transfer the samples, and then have the orbiter fly back to Earth, dropping the sample capsule into the Utah desert, the way the OSIRIS-REx mission returns samples from asteroid Bennu. Ambitious, visionary, and horrifically expensive. An independent review in 2023 projected the cost at $11 billion. $11 billion! And the timeline? The samples wouldn't return until 2040. 25 years after Perseverance landed. By then, everyone working on the mission would be retired. Some would be dead. And NASA's science budget simply can't support an $11 billion mission without cannibalizing every other planetary science program in development. So, in April 2024, NASA Administrator Bill Nelson stood before the press and said the unthinkable. $11 billion is too expensive, and 2040 is unacceptably too long. The agency would solicit new proposals from private companies and NASA centers, cheaper designs, faster missions. SpaceX submitted a proposal involving Starship. Rocket Lab claimed they could do it for $4 billion by 2031. Blue Origin offered alternatives. And then, in May 2025, the Trump administration released its proposed budget for NASA, a budget that slashed science funding by nearly half, a budget that zeroed out Mars sample return entirely. The reasoning? The mission is grossly over budget, and its goals would be achieved by human missions to Mars. Except humans aren't going to Mars anytime soon, not in the next decade, possibly not in the next 2 decades. And the Cheyava Falls sample, sitting in a sealed tube inside Perseverance's belly, won't wait that long. The rover's plutonium power source has about 10 years of life left. After that, Perseverance will go silent, and the samples, containing what may be the most important scientific discovery in human history, will sit on Mars forever, gathering dust, unreachable. Dr. Katie Stack Morgan, Perseverance's project scientist, tried to remain optimistic during press conferences. "We are exploring options. We're working with industry partners. We believe there's a path forward." But privately, many scientists are less hopeful. The political will to fund Mars sample return seems to be evaporating. Congress is divided. Budget constraints are tightening. And even if a mission is approved, it won't launch for years. The earliest any redesigned mission could return samples is 2035, more realistically, 2039. By then, Perseverance may be dead. The samples may be contaminated by Martian dust storms or damaged by radiation. And the window to definitively answer the question, did life ever exist on Mars, may have closed.
But let's assume for a moment that the samples do come back. Let's imagine a future where a capsule screams through Earth's atmosphere and lands in the desert, carrying Cheyava Falls inside. What happens next? The samples would be taken to a specially constructed biosafety facility designed to prevent any possible Martian contamination from escaping into Earth's environment. Scientists would slice the rock into sections. They would peer at it through electron microscopes. They would analyze isotopes. They would search for fossilized cellular structures, the microscopic remnants of ancient organisms. And if they found them, if the evidence was undeniable, the announcement would change civilization. But even then, questions would remain. If life existed on Mars, where did it come from? Did it originate independently, proving that life arises wherever conditions allow? Or did it come from Earth? Meteorite impacts can blast rocks off one planet and send them hurtling through space to land on another. Scientists have found Martian meteorites on Earth. It's possible that Earth rocks carrying microbes crashed onto Mars billions of years ago and seeded the planet with life. If that's true, then finding life on Mars doesn't prove life is common. It just proves life is resilient enough to survive an interplanetary journey. And the question of whether we're alone in the universe remains unanswered. Or perhaps it went the other way. Perhaps life originated on Mars first, back when the planet was warmer and wetter, and then spread to Earth via meteorites. If that's true, then we are Martians. Our entire evolutionary tree, everything from bacteria to humans, descended from organisms that first evolved on the red planet. We didn't come from Mars. We are Mars.
That idea, as strange as it sounds, is taken seriously by some astrobiologists. Mars was habitable earlier than Earth. Its smaller size meant it cooled faster. Liquid water existed on Mars before Earth's surface had solidified. If life is easy to start, then maybe Mars got there first, and maybe 4 billion years ago, a chunk of Martian rock carrying primitive cells crashed into the young Earth and sparked the beginning of our story. The third possibility is the most profound. Life originated on Mars. Life originated on Earth. Separately, independently, two different chemistries, two different evolutionary paths. That would prove beyond any doubt that life is not a miracle. It's not a one-in-a-universe accident. It's a natural consequence of chemistry and physics. And if it happened twice in one solar system, then it's happening everywhere. The galaxy is alive. The universe is teeming with organisms, most of them nothing like us, thriving in environments we can barely imagine. But we don't have those answers yet. We have a rock with leopard spots. We have minerals that might mean life. We have questions piled on top of questions. And we have scientists tearing their hair out because the one piece of evidence that could settle everything is trapped on another planet, and no one knows when or if it's coming home. Let's talk about what we know for certain. Mars was once a very different world. The evidence for this is overwhelming. Orbital images show dried riverbeds, massive canyons carved by flowing water, deltas where rivers emptied into ancient seas. The Curiosity rover, Perseverance's older sibling exploring Gale Crater, has found mudstones, clays, and sulfates, all minerals that form in the presence of liquid water. Measurements of atmospheric composition reveal that Mars once had a much thicker atmosphere, warm enough to keep water liquid on the surface. And then, somewhere around 3.5 billion years ago, something catastrophic happened. Mars' magnetic field died. Without a magnetic field to shield the atmosphere from the solar wind, the sun's radiation stripped away the air, molecule by molecule, over millions of years. The atmosphere thinned, the pressure dropped, water evaporated or froze, the rivers dried up, the lakes vanished, and the surface became the frozen, irradiated wasteland we see today. If life existed during the wet era, it faced a crisis: adapt or die. On Earth, when environments become hostile, life retreats underground. Deep aquifers, caves, pockets of liquid water trapped miles beneath the surface, heated by geothermal energy. Could life still exist in Mars's subsurface today, clinging to existence in isolated pockets, waiting to be discovered? Some scientists think so. NASA is planning missions to search for subsurface water using ground-penetrating radar. But drilling miles into the Martian crust is beyond our current technology. If life is hiding down there, it'll be decades before we can reach it.
But Cheyava Falls isn't about subsurface life. It's about the past, about a time when Mars was habitable, when rivers flowed and lakes filled and organic molecules accumulated in sediment. A time when, if life ever had a chance on Mars, this was it. And the leopard spots suggest that chance was taken. Something consumed those organic molecules. Something used iron and phosphorus in chemical reactions. Something left behind a pattern that, on Earth, we associate almost exclusively with biology. Dr. David Flannery, an astrobiologist at the Queensland University of Technology and part of the Perseverance team, called the leopard spots a big surprise. Dr. Morgan Cable, another team member, described them as exactly the kind of biosignature the mission was designed to find. And yet, the team is careful. frustratingly careful because they know the stakes. They know that announcing the discovery of life on Mars without absolute proof would be the worst mistake in the history of science. They remember the Viking landers in 1976, which conducted experiments that some interpreted as detecting life, only to have those results debated and ultimately dismissed. They remember the Martian meteorite AL84001, found in Antarctica in 1984, which contained structures that some scientists claimed were fossilized bacteria, sparking massive controversy and years of heated arguments before the consensus shifted toward non-biological explanations. NASA has been burned before, and they're not going to let it happen again. So, they use phrases like potential biosignature. They publish peer-reviewed papers in Nature, one of the most prestigious scientific journals in the world, laying out the evidence and the uncertainties. They present their findings at conferences, inviting criticism, welcoming skepticism, because that's how science works. You don't announce a discovery and declare victory. You present your data, and you let the scientific community tear it apart. If it survives the scrutiny, if no one can find a better explanation, then maybe, just maybe, you start to believe you're right. As of right now, the scientific consensus is cautious. The Cheyava Falls sample is the most compelling potential biosignature ever found on Mars, but the evidence is not conclusive. Alternative explanations exist, and until those samples come back to Earth and are studied in labs with equipment far more sophisticated than anything on Perseverance, the question remains open. We don't know. We're close, closer than we've ever been, but we don't know. And so we're left in limbo. The sample sits on Mars. Perseverance continues its mission, slowly climbing the rim of Jezero crater, searching for more rocks, drilling more cores, hoping that one of them will be the smoking gun that removes all doubt. But the clock is ticking. The rover's power is finite. The budget for Mars sample return is disappearing, and the window to bring those samples home is closing. Some scientists are advocating for a crash program, a stripped-down mission that skips the fancy rockets and helicopters and just sends a simple lander with a return vehicle. Get the samples, get out, worry about cost and elegance later. Others argue that any mission worth doing should be done right, and that rushing will lead to failures that set the program back even further. And politicians, the ones who control the purse strings, are focused on other priorities, human missions to the moon.
National security, budget deficits, Mars sample return is expensive. It's risky, and it doesn't have a constituency that's willing to fight for it the way the Apollo program did. But here's what haunts me. Here's the thought that keeps me up at night. What if Cheyava Falls is the answer? What if that rock, sitting in a tube on the Martian surface right now, contains definitive proof that life once existed on another world? What if we're one analysis away from answering the oldest question humanity has ever asked? And what if, because of budgets and politics and bureaucratic inertia, we never find out? What if 100 years from now that sample is still sitting there, degrading slowly under the Martian sun, while future generations curse us for being so close and giving up? Or worse, what if China gets there first? The Chinese Space Agency has announced plans for their own Mars sample return mission, launching in 2028 and returning samples by 2031. A simpler mission than NASA's, fewer samples, less ambitious, but potentially faster. If Chinese scientists are the ones who confirm life on Mars, how will history judge America's decision to abandon its own mission? How will we explain that we were there first, we found the evidence first, and then we walked away because we couldn't figure out how to pay for it? The irony is staggering. We live in an era where private companies are launching rockets every week, where SpaceX is building Starship, a vehicle designed to carry 100 tons to Mars, where the technology to retrieve those samples exists and is improving every year. The problem isn't capability, it's will, it's priority, it's the inability of our civilization to look beyond quarterly budgets and election cycles and commit to something that matters on a cosmic scale. Because make no mistake, this matters. If life existed on Mars, then life is probably common throughout the universe. Every star has planets. Some of those planets are inhabitable zones. If life can start on 2 planets in one solar system, then it's starting everywhere, and that changes everything. Our place in the cosmos, our understanding of biology, our search for intelligence beyond Earth, everything. And if life didn't exist on Mars, that's important too, because it would tell us that life is rare, that Earth is special, that the conditions required for biology to emerge are more specific, more fragile than we thought. And that would make the preservation of life on Earth all the more critical, because we might be alone in a vast and empty universe. Either answer reshapes our worldview. Either answer is worth knowing, and right now, the answer is sitting in a titanium tube on a dead planet, waiting for someone to care enough to bring it home.
There's a document that NASA scientists use called the Confidence of Life Detection Scale, or COLD scale. It's a 7-step ladder that describes how confident we can be that we've detected evidence of life. Step 1 is possible signal. That's where Cheyava Falls is right now. We've seen something interesting, something consistent with biology, but also consistent with other explanations. Step 7 is life detected with high confidence. That's where we need to be. That's where conclusive evidence, examined in Earth labs, scrutinized by thousands of scientists, confirmed through multiple independent analyses, tells us without doubt that we found it. Life beyond Earth. The gap between Step 1 and Step 7 is enormous, and right now we're stuck, frozen in place, unable to move forward because the next steps require bringing the samples home, and we can't do that without money, without political support, without a mission that works. The scientists who work on Perseverance are, by all accounts, some of the most dedicated people on Earth. They've spent years of their lives on this mission. Some of them have spent entire careers preparing for this moment. They've designed instruments, they've written software, they've guided the rover across millions of miles of Martian terrain, and now they're watching as the samples they've worked so hard to collect sit in storage with no clear path to retrieval. It's heartbreaking, and it's maddening. Dr. Joel Hurwitz, when asked about the future of the samples, said simply, "We hope someday they'll be brought to Earth for detailed study." Hope, that's what it's come down to. Not certainty, not plans. Hope. And yet, despite everything, the work continues. Perseverance is still driving, still drilling, still collecting samples, because that's what scientists do. They keep working, even when the odds are against them, even when funding dries up and missions get canceled and politicians lose interest. They keep searching, because the universe doesn't care about our budgets or our timelines. The truth is out there, waiting to be discovered, and someone has to be stubborn enough, passionate enough, idealistic enough to keep looking. Cheyava Falls is not the end of the story, it's the beginning. Whether those samples come back in 5 years or 50, whether NASA retrieves them, or China does, or some future mission we haven't imagined yet, the question they pose will not go away. Did life exist on Mars? The rock knows the answer, the minerals remember, and someday someone will bring that memory back to Earth and we will finally know. Until then, we wait, we watch, we hope, and we stare up at the night sky, at that pale red dot hanging among the stars, and we wonder, what secrets are you hiding, Mars? What stories are written in your rocks? And will we ever be brave enough, determined enough, patient enough to find out? The leopard spots are waiting, the truth is waiting, and time, as always, is running out.